Okay, so I'm going to try to help you with your take-home quiz for Chapter 11 that you got today in class. Hopefully this helps you. Um, what I'm going to say most importantly is that you read the paragraph. I had a couple of you who were trying to answer the questions without actually reading the paragraph. If you read the paragraph, you'll realize that you actually get some answers to some of the questions, especially like questions numbers 1 and 2, where they actually tell you in the paragraph that the reaction between magnesium and oxygen produces magnesium oxide, and also the reaction between magnesium and nitrogen produces magnesium nitride. So you want to go ahead and make sure that you read the full um, paragraph carefully. It isn't just there for show. Okay? Now, let's take a look at the different types of reactions that we've been talking about in class, because that's important, because there's a lot of questions that ask you to classify reactions. So the first type that we did talk about was synthesis. And a synthesis reaction simply is going to be you have two elements combining to form a product. So in this case we have element A combining with element B, which is going to form compound AB. Please see your notes for examples. We also have a single replacement reaction. And let's go ahead and stave off keep our single replacement reactions for a little later. Actually, as soon as we're done talking about our um, composition reaction. So we have our decomposition reaction, which is the opposite of your synthesis. And your decomposition reaction is, like I said, it's the opposite. So that's where you have compound that's made up of elements A and B, and they decompose or break apart to form the elemental components, which in this case are A and B. Like I said, we'll talk about your replacement reaction. There's two types of replacement reactions. One is your single replacement reaction, and in the single replacement reaction, you have a metal that's replacing another metal. In this case, we're going to use element A, which we're going to suppose is a metal, and you have compound BX, where B is the metal and X is a nonmetal, it's like an ionic compound. And A, if it is more reactive than B, will replace it in the reaction, and we'll end up with compound AX, and element B will be by itself. Like I said again, please make sure that you look into your notes for examples. I'm not going to go into actual examples, especially since this is a quiz. You also have your double replacement reactions. In double replacement reactions, again, if we have element A, compound AX combining with BY, and again, these are generic formulas, what we know will happen is that your element B will replace element A, and element A will replace element B in this reaction here, in a double replacement reaction, if it does occur. In this case, element A will combine with Y, so you have AY plus BX, which would be your resulting thing. Now remember, with the double replacement reaction, we said that there's several things that can occur with a double replacement reaction. You can have the formation of a gas, the formation of a precipitate, and even the formation of water. You will need to go ahead and look on page 344 in the text, and that will give you your solubility rules that you need to follow. So you need that for your double replacement reaction, and then with your single replacement reaction, you actually need to know your metal reactivity series. And I think that comes up on page 333. And I think your solubility rules are on page 344 of your text. So you probably want to go ahead and take a look at those. I did mention in class that your metal reactivity series needs to be memorized. The one in the textbook is the one that I would like you to memorize, and I'll try to stick to using those on the test. If not, I'll give you the reactivity series that I would like you to use. Solubility rules, you really do need to know those, but I will allow you to use a copy of those on your test. I did give you a worksheet a while back that you had to do back on I want to say it was like the 27th on the 27th of January, that had a copy of the metal reactivity of the solubility rules that you could use. It was called net ionic equations, and it was worksheet 10-4. You can tear that out and use it on your test. All right. In your double replacement reaction, it's important for you to remember that these are ionic compounds, and ionic compounds are composed of a cation and an anion. So your cation is always going to replace your cation in the reactions, okay? Um, and again, ionic compounds are made up of a metal bonded to a nonmetal, so try to remember all of those. The last one that we did talk about was your combustion reaction. A combustion reaction, notice sometimes I write reaction completely out, or I write RXN, and that's just a shorthand way of writing it. Your combustion reaction is simply an element A combining with oxygen, and in some cases, not all cases, where heat is given off, and you're going to end up with some type of oxide, okay? And again, the formula is not as simple here, but it just depends. It could be, you know, carbon and oxygen, carbon dioxide, that will be CO2, and so, but please again, refer to your notes for examples of each type of the reactions. Now, what I am going to do for you is, since we already did number one in class, I'm just going to give you a couple of hints to help you with each of the questions, and then you can, fast forward, rewind, and do whatever you need to do. With question number two, again, I showed you that earlier at the beginning. Make sure that you read the paragraph and find the product of magnesium and nitrogen. What I want you to remember, what it requires that you remember is that magnesium is in group 2A, and those are elements that are to the left, far left on the periodic table, generally form cations. And so a cation has a positive charge, and so magnesium is in group 2A, and so it forms 2+ ions. Nitrogen, on the other hand, is on the far right of the periodic table. Nitrogen is in group 5. Elements in group 5A tend to form anions. Sorry about that. And because it's in group 5A, it is going to want to form a 3- ions, because nitrogen would actually rather gain electrons than opposed to losing electrons. So it's going to gain 3 negative charges. So what you have here is simple little formula that you need to come up with, which has your magnesium ions combining with your nitrogen ions. We've done this in class also. Remember, your charge is going to become your subscript, so you could use your crisscross method, and then using the crisscross method, you should be able to come up with the formula on your own here. So I am not going to write the formula for you, of course. Once you do that, this will be your product. Once you figure that out, you need to make sure that you remember that nitrogen is also diatomic. You guys are really not remembering that. Those are your genuine molecules. So Um, and again, go back to your notes on that. Okay, I'm not going to go through that again because if you don't remember, you're going to have a difficult time balancing this equation. So that will help you with question number 2. Question number 3, again, that's another writing the equation and balancing it. That you're looking at combining magnesium with dry ice, and if you read carefully, you'll see dry ice is carbon dioxide. You want to write that equation, and it tells you what product is formed in the question itself. So please make sure you look at that, and then we also need you to write and balance that equation for question number 3. Okay. Question number 4 and question number 4. Again, it's a pretty similar question. It tells you what it reacts with. I mean, if you don't know the formula for water, then I mean, we're having some trouble if you can't remember the formula for water. You should be able to write that. And again, remember, hydrogen is diatomic. It's one of the genuine molecules. So you need to make sure that when you write that as a product on the right side of the arrow, that you have the correct formula for hydrogen. Okay, I know it sounds weird, but you gotta have the correct formula. Question numbers 5 and 6. Again, with question number 5 and 6, please make sure you read numbers 3 and 4. Okay, question numbers 3 and 4 actually give you the answers to question 5 and 6. It just requires just a little bit of reading comprehension. There's nothing for you to work out in question 5 and 6, but you will need to read it carefully to see if you can answer. Question number 7. It's not as tricky as it appears. Question number 7, when you have zinc solid, please remember that that zinc is in a solid. It's not aqueous solution, so it will not break down into ions. So it's not ionic. So you have to keep it as is on the reactant side. The only thing on the reactant side that is in an aqueous solution and is an ionic compound is your silver nitrate. And your silver nitrate then can be broken down into its ions when you're getting ready to write your ionic equation. Same thing for the reactant, the product side, and I'm going to let you do that on your own. On question number 8, now I'm going to finish up right here. Silver is an ionic compound, and if you look at your common cation and anion sheet, I'm sure you will see this polyatomic anion, and you should be able to determine your charge. So please go ahead and look at your polyatomic anion and cation sheet to help you with that. Again, like I said, this is, don't make things more difficult. This is a polyatomic. Yes, it's more than 2, but that's fine also. Okay. So hopefully this helps you. Again, like I said, hopefully you can rewind and